Hi there, and welcome to this video on slope. Slope is an absolutely critical concept for algebra and beyond. And so if this video is a little bit longer than normal, it's because it's such an important concept. When we get something this critical that's going to come back over and over and over again, we don't want to rush through it and we don't want to leave gaps where there's potential misunderstanding. So bear with me on that. If I'm going to do it, I want to do it right. Please like this video if you find it helpful and subscribe to the channel for more math content. Drop a comment or a question below. Let me know what you think of this lesson. So the key idea, we're going to look at this key idea a couple times. The steepness of a line is the same everywhere. And so I'm going to pull up this grid here. So if you picture the red line here as being a hill and you're climbing up the hill, the steepness of the hill is the same whether you're down here at the bottom or coming up here at the top. And in other words, it doesn't curve. Now, in real outside of math life, we do talk about like curvy lines and stuff, but in math, it's really important to know that when we're talking about a line, that we mean that the steepness is the same everywhere. In other words, all lines are straight. So no matter where we go on the line, the steepness is the same. So I mentioned like hiking up a hill. If you were hiking up this red line, it would be the same steepness everywhere. Now, if you were looking at this purple line, okay, you would say, well, that's like much, much steeper. Okay, so that's like an intense hike. Maybe skiing down a mountain would be this green one, and you start at the top and you go to the bottom, but it never levels off. Imagine going down that slope where it never levels off. Okay, so the steepness of a line is the same everywhere. Now, what we could use is a way to quantify the steepness of a line. And just so we know, quantify means to assign a number to it. So right now, I could say, well, the purple line is steeper than the red line. And that's true. But it doesn't tell me much about it. It's what's called a qualitative statement. What would be more useful is if I had a number, if I had a way to measure how steep the line is. Then I could say, well, the red line has a steepness of blank and the purple line has a steepness of, and it would be something different. And now I have these two numbers that I can actually compare, and I can maybe answer the question, well, how much steeper? Like, I don't just say a lot steeper. And that introduces a key concept about lines, but also the idea that we have a need to be able to measure exactly how steep the line is. Or like this line here, the green one is tilting down instead of tilting up as we go from left to right. How would I want to quantify that? So looking at this, so what I did, these are the same three lines. I just put the coordinate plane in back of it. So instead of a bare X and Y axis, we now have the numbers. So of course, if we want to quantify it, then we want to have some numbers. We do this by determining the ratio of how much the line goes up or down to how much the line goes right or left. Now, typically we will talk about up and down, and typically we will look at going to the right as opposed to going to the left, but you could work this going to the left as well. You just have to be mindful of positives and negatives. And so a ratio, of course, can be written as a fraction. And so what we've got there is we've got the up down part on the top, and we have the left right part on the bottom. Okay, and so we look at that. Now, I want to look at each of these lines individually for a moment. If we look at the red line goes up 1 unit for every 3 units it goes to the right. So come with me over here. If I pick a point on the line, okay, so I see the point 3, 2, and then I see the point 6, 3. I go up 1 unit and over 3 units. But I could actually like pick that somewhere else. So I see like another point right there at -3, 0. And then 0, 1, I go up 1 unit and over 3 units. And that's the same everywhere on that line. We're going to look at that in more detail. And so if I take that ratio, I have up 1. So the 1 is in the numerator. And I'm going to the right 3. Okay, and so we could quantify the steepness of that line by saying, well, it goes up 1 unit for every 3 units. Now, by contrast, the purple line, we know the purple line is steeper. Okay, we already established that. But how much steeper? Well, the purple line goes up 4 units for every 1 unit to the right. So if I find a point right there, that looks like the point -2, -6, and I go up 1, 2, 3, 4, there's my other point. And you can see as I'm drawing it on there, I go up 1 unit, 4 units for every 1 unit that we're moving to the right. And so that would be the ratio of 4/1. Okay, which 4/1 simplifies to just 4. And so now, instead of just saying, well, the purple line is steeper than the red line, I actually have a number I can put with it. I can say the red line has a steepness of 1/3 and the purple line has a steepness of 4. And so you're getting the idea, well, yeah, it's steeper. Look at how much. You can compare the 1/3 and the 4. So we've quantified it. We've put this number on it. Now, let's take a look at that green one. That green one is a little bit different. The green line actually goes down 5 units for every 1 unit. And so if I look at the green line and I find a point on the green line, here's a point, the point 2, 0, and then I go and find another point. So that looks like 3, -5. I'm going down 5 units for every 1 unit that I'm going over. And the way we represent that in our ratio is with the negative there. And so we indicate that it is going down by saying negative. And so -5 compared to a 1 would simplify to 5. Now, what that tells me is a couple things. It does tell me that if the line is tilting down, then we're going to use that negative to indicate, yes, we are moving down. But notice that we can use what's called the magnitude or the absolute value of that to determine that the green line actually is steeper than the purple line because it's changing more for each unit. It's just heading in a different direction. So the negative tells us which direction the line is going, whether the line is tilting up or tilting down. And then the number part tells us how steep it is. So green is actually a steeper line, but going in another direction. So that introduces you to the basic idea of slope. We call that ratio the slope of the line. So the key idea, coming back to that key idea, or just rephrasing it, if you pick any 2 points on the same line, you will always get the same slope. So I put a line on here and we're just going to look at several examples. So follow along as we do this. Well, I can go with green. So I'm going to go ahead and pick that point and that point. All right. And so I'm going to kind of make this little triangle here, and we're going to find out how far up or down are we going. So in this example, I'm going down 1, 2, 3, 4, 5, 6 units. Make sure that you are counting spaces, not the lines. Okay. I've had plenty of students count lines, so you're counting how many spaces you move. So I move 1, 2, 3, 4, 5, 6 spaces. And so I'll say that is 6, but I'll make it negative because I was going down. And then going over 1, 2, 3, 4. So I went down 6 spaces for 4 spaces to the right, and I can simplify that fraction. That fraction simplifies to -3/2. All right, let's take this point and this point. All right, so I'm going to kind of sketch this in and see what we got going on. So in this example, I am moving down 1, 2, 3. So I moved down 3 and over 1, 2, and that was in the positive direction. And notice that we got the same slope there. Okay, so -3/2. And you could do this. We'll do one more example. Let's go from this point here all the way down to this point here. So I'm gonna sketch this in. Okay, and we look at that, and then we need to count how far down did we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like we went down 9 and over 1, 2, 3, 4, 5, 6. And 9 over 6 will simplify. You can divide both of those by 3 to negative 3 halves, and you'll notice we get the same thing. So it doesn't matter. And we could also count in the other direction if you wanted to. Now, we don't usually do that, but I'll go ahead and pick, I don't know which ones I'll pick. We'll pick these 2 points. Somebody might kind of count this way. Okay, and they might say, okay, well, in this example, I'm counting, like I'm kind of counting from right to left. Now, usually we don't do that. Okay, usually we count the other way, but sometimes it depends on what points are on like your line, like where you have good points. And so sometimes it's useful to just know that you could count the other direction if you wanted to. So to get from one point to the other, we went up 1, 2, 3. So this time we went up 3, but we are going left 1, 2. And so I'm actually heading like to the left on that number line. And if you've been following these videos for the duration, you know that I mentioned like your number lines are super, super useful, and being able to picture like the left and the right on the number line, this is a good place where that can come into play. So the negative signifies, again, the direction. Now we know from our signed numbers that a negative divided by a positive is negative. But we also know that a positive divided by a negative would also be negative. And so you can kind of move that negative like wherever you want. You can put it on the outside. Yeah, or you can move it to the numerator. So you end up with the same slope either way. So really, really key idea when we're talking about lines in math is that the slope is the same everywhere. It gives us this way to quantify how steep the line is, and you can pick any 2 points on the line and calculate the slope from those points on the line. So the symbol for slope is a lowercase m. Now there will be some points later in your math where you might see a b used for the slope. Not anytime soon. It's usually when you get into what are called higher order polynomials, and you just use like a, b, and c, and b just means like the second like coefficient, or it's like the number multiplying the x. Okay, don't worry about that for now. A lot of students think of this as like mountain. Okay, so M for mountain, and it tells you how steep it is. There are several ways to think about slope. And again, if you've followed these videos for the duration, you know that I've talked about the importance of having a representation in your head, a way to picture and understand a concept. And so these are some of the ways people consider the concept of slope. This is super, super common. It's the slope is the rise over the run. People like it because it has that nice alliteration with the 2 R words, and the rise signifies how much you are going up or down. Okay, so rise like an elevator, and then the run is how much you're going left and right. So you can picture yourself like running on a flat, track. And so rise over run is your up, down over your left, right. You will hear that a lot. Again, it has that nice little alliteration to it. This one I have not seen as much recently. This triangle that you see there is the Greek letter delta. And it means in mathematics the change in. And so this would be the change in y over the change in x. In other words, how much do I go up and down compared to how much I go left and right? So how much is my y changing over how much is my x changing? And that Greek letter, you will see that again as well. This one we're going to spend some time camped out at. This is a formula that I don't want to just like hit you with the formula because I want you to know where it comes from. But this is a formula for calculating slope. And I've had a lot of students ask me about the subscripts. Okay, so that is y sub 2. I'm going to write that out because I was confused about that the whole time I was in Algebra 1. Y sub 2 minus y sub 1. And that is short for subscripts. So sub means under, like a submarine travels under the surface of the water, and script means writing. And so a subscript is underwriting. It's writing that's a little bit underneath the level of the y, as opposed to an exponent, okay? That is x squared. That is a superscript. meaning it is written above. Super would be like above, like if you were super, you were like the top, okay? Where this would be y or x sub 2, meaning a subscript of 2. So they are not the same thing, okay? A colleague of mine recently graded some work for an honors algebra 2 class where a student was using exponents instead of subscripts. So this is a common misconception, so we want to make sure that we're clear on it. The 1 and the 2 are simply to differentiate between the 2 points. So if you think back to what I was doing, every time I was finding the slope, I was picking 2 points. And so the subscripts are just a way of saying, hey, that's 0.1 and that's 0.2. And so you've got the y for the second point minus the y from the first point over the x from the second minus the x from the first. We'll look at that in more detail. Now, average rate of change. This is actually very common, especially when you get to pre-calculus, but this is what we do in application problems a lot. And so if you check out the practice set, which I definitely want you to do for this, you can see like on a graph what the slope represents, and it's some kind of rate of change. So how much is one changing compared to the other? So we're going to explore that third one further. Okay, we're going to look more in detail at that one. So looking at these, this line, suppose we want to find the slope. Now we could count it, all right, but there are reasons why we're not necessarily interested in counting. So consider the specific coordinates of these 2 points. So this is the point 3, 2, and this is the point 5, 6. And if I wanted to get the location of that point up in the corner there, it's got the x coordinate of that first point, so 3, but it's got the y coordinate of the second point. So that point up in the corner there is 3, 6. That may or may not be helpful to you. Now, what would I need to do with those numbers to find that vertical change? So obviously you have the option of just counting, an option that way too many of my students do not take advantage of. Okay, they don't realize, hey, I could just count this, and instead they jump to the formula. But if you look at the y coordinates, on these 2 points. So we want to find out like how long is that point there. You're at 6, and from 2 to 6, that's the distance there. What you could do is you could subtract the y coordinates. So if you said 6 minus 2 and you could get 4, that would tell you that distance there. And you could do something similar with the horizontal. So with the horizontal, you're moving this way, okay? So if you look over on the graph there, and your y coordinates are the same, but you're starting at that 3 and moving over to the 5, and so you could subtract there, and that would give you that distance. So that is 5 minus 3, which is 2. Thus, the slope is, well, we went up, so we went up 4, and we went over 2, and 4 divided by 2 is 2. So the slope is 2. Now you could also get that by counting. So you could say I went up 1, 2, 3, 4 and over 2. But this is important, okay, this idea of subtracting. So what we could say is that if we wanted to find the slope, basically I have to subtract the y's and subtract the x's and divide. And that would give me my steepness. Okay, that's where that formula comes from. Now that also works if you have negative numbers. I'm not going to demonstrate it with the negative numbers because that makes the arithmetic all hairy and can make it harder for you to see what we're doing there. But it does work with negative numbers. I will have a word to say about that. All right, so what does that mean? What it means is that you don't need to see a graph in order to find the slope. All you need are just 2 points. And this is good because not all points are convenient to graph. So while you might think, oh, well, I could just graph them and count them all the time. Well, if you look at these points, like, do you really want to count from 25 up to 100? No. In fact, even as I said that, you could say, well, I wouldn't have to get from 25 to 100, that would be 75. Yes, and you got that by subtracting. So if we take a look at how we work this out, you need to pick a point for being 0.1 and a point for being 0.2. Now, it doesn't matter which one you pick for which. So I'm just going to go ahead and say that this is 0.1 and this is 0.2. Okay. Oh, didn't mean to hit that. Okay, so when you have 0.1, that makes this x1 and y1. And again, that 1 is just making sure that our x's and our y's look different. So that is the x for 0.1 and the y for 0.1. And this is the x for 0.2 and the y for 0.2. I strongly encourage you to copy down this formula. Okay, like strongly encourage you to copy down that formula until it is locked in your brain. Y2 is 30. Y1 is 100. X2 is 25. And, oh, wait a minute. I did that wrong. Don't do what I just did. We had the 30 and that should be 50. Sorry about that. At least I caught it before I finished the problem. X2 is 25 and X1 is 100. So 30. Now, if you want to here, you can kind of kick over to plus negative. Okay, so 30 plus negative 50 is negative 20. 25 plus negative 100 is negative 75. And I believe we can simplify that. So we could divide by 5 and like I should have this somewhere else, 4 over 15. And note that a negative divided by a negative is going to give you a positive. Okay, so that simplifies to 4 over 15. So that gives us the slope of that line. Now, over on the right, what would happen if we had labeled the points differently? So instead of making 0.1, the one that I did, I said, okay, 150, we're going to make that 0.2, and the 25, 30, we're going to make that 0.1. All right, so how is that going to work out? So here's my formula. And this time y2, so this is x2, y2, and this is x1, y1. Y2 is 50. Y1 is 30. X2 is 100. And x1 is 25. 50 minus 30 is 20. 100 minus 25 is 75. And lo and behold, we get the exact same slope, 4 over 15. So moral there is it does not matter which point you pick as 0.1 and which point you pick as point. We've been working all day. Which point you pick as 0.2, as long as you're consistent with it, you should get the same one, same point slope every time. There is often a nice way to pick them and a not so nice way to pick them, and you can get that with practice. So a couple points of caution, and I just kind of alluded to this. Once you pick 0.1 and 0.2, you have to keep that choice. Okay, so again, it does not matter which point is 0.1 and which point is 0.2. I often ask my students that is what I call a free question. You cannot get this wrong. Just give me a point. But once you make that choice, you have to be consistent. So this will not work. If you have y2 minus y1, and then you decide, oh, well, I don't like negative numbers or something, and you try to switch them, that will not work. Okay, so we're gonna no, do not do that. Okay, do not do that. It will give you the right number, but the wrong sign. So it will cause your slope to be positive when it should be negative, or negative when it should be positive. So pick these however you want, just be consistent. And watch out when you're subtracting a negative. So in this one, I think I have this one as x2, y2, and x1, y1. So you've got y2, which is 5, minus y1, which is 4, which is fine. But when you go to do the x's, you have -3 minus -5. And so this minus is in the formula. If you recall, the formula comes with a minus sign in it. Okay, this minus sign is coming in with the number. Okay, and so you actually end up with minus a negative. This is where it's super helpful to remember that subtraction is addition of the opposite. And so in that particular problem, you could write it as 5 minus 4 over negative 3 plus 5, because subtraction means adding the opposite, and the opposite of negative 5 is positive 5. So that ends up being negative 3 plus 5. And that ends up being what, 1 over 2 for your slope there. So just caution with the negative numbers. Absolutely doable. No reason why you've got to get it wrong, but it is like heads up, slow down. Yeah, heads up, slow down. Okay. So please check out the practice set. There are some problems to help you recognize some patterns in the slope as we move forward. This is going to be very useful to just be familiar with that. I'll link that in the description box. I'll also link a card up on this slide somewhere. Don't forget to like this video. Super easy to hit the thumbs up if it was helpful. Subscribe for more math content, and I'd love to hear your comments and questions. I will see you in the next one.